Hello my dear students, welcome to the chemistry classes. In this class we are going to discuss about the continued part of the chapter D and F log elements. In the previous session of this chapter we have discussed about the general introduction of the periodic table, general classification of the periodic table, and also we have discussed about the especially D block elements, especially properties of physical properties of D block elements, and also we have discussed about the classification of the D block elements and electronic configuration of the 3D series of elements. In the previous session we have discussed the detailed electronic configuration of the 3D series of elements. It means in the 3D series of elements, it means 3D series of elements, there are totally 10 elements are there. Totally 10 elements are there. Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper and zinc. There are totally 10 elements are there. Scandium to zinc, there are 10 elements are there from atomic number 21, 22, 23, 24, 25, 26, 27, 28, 29 and 30. Totally 10 elements are there in the 3D series. It means these are the 3D series of elements. These can be categorized under the D block elements. It means why these can be classified under D block elements means the added electron will enter into the partially filled or empty D orbital. Hence these are called as the D block elements, especially 3D series of elements. This is the first transition series of elements. Next, in this 3D series of element, in this class we are going to discuss about the general trends or properties of 3D series of element. General trends or properties of 3D series of elements. General trends or properties of 3D series elements. First property, atomic radius. First property is atomic radius. Already you know about there is a slight change in the periodic table in the atomic radius of the periodic table. It means as we move from left to the right and top to the bottom, it means totally there are 18 groups from left to the right. From left to the right 18 groups and 7 periods from top to the bottom in the periodic table. This is the initial classification of the periodic table. 7 periods and 18 groups. 18 groups means from left to the right. Next, a period means from top to the bottom there are 7 periods are there, 18 groups are there. It means in the 18 groups, as we move from left to the right, and as we move from top to the bottom, there is a slight change in the atomic radius. Our atomic radius is nothing but this is a circle. This is a circle. In this circle, the distance from center to the circumference is called as the radius. Like this, the atom also will be visible. The atom also is in the form of circular form. It means at the center of the circle there are protons and neutrons are there, and the electrons are revolving around the nucleus in a fixed circular path. This is the concept of the atom. It means all the elements are considered in the form of an atom. Like this, we can consider the atom. It means in the all the elements of the periodic table, all the elements of the periodic table having the respective atomic radius. It means then along the series what will happen and along the group what will happen we should know. It means along the group, it means along the group means from top to the bottom, and along the period means from left to the right. There will be a slight change in the atomic radius. It means atomic radius means from the nucleus to the outermost electron or outermost shell. There is a distance between the nucleus. It means consider this is an atom. This atom having the different orbits. This is the K shell, L shell, M shell, like this. This is K shell, L, M shell, N shell, like this. We can classify this in the first orbit, second orbit, third orbit, fourth orbit. Like this we can classify. Then from this nucleus to first orbit, this is the first atomic radius. From this nucleus to second orbit, this is the second atomic radius. Then nucleus to third orbit, this is the third atomic radius. Next nucleus to fourth orbit, this is the fourth atomic radius. Like this we can identify the atomic radius for the each element and each atom. In this series of elements, especially in the periodic table, as we move from left to the right, there will be a decrease in the atomic radius. Already you know this concept. It means as we move from left to the right in the periodic table, there is a decrease in the atomic radius because all the electrons will adding into the same shell. All the electrons are adding into the same shell, and as a result there will be a increase in the effective nuclear charge, then it will decrease the atomic radius. Next, as we move from top to the bottom, there will be a decrease in the there will be a increase in the atomic radius. This is due to the adding of new shell. It means there will be an increase in the new shell. It means if this is the first series element, there is a one shell. If this is a second series element, the second shell. If there is a third series element, third shell. Like this, atomic radius going to increase as we move from top to the bottom. This is the general concept for the periodic table. Next, as we apply this concept to the 3D series of elements, there will be a slight change in the atomic radius. There will be a slight change in the atomic radius. See here. As we apply this concept to the 3D series of element, there will be a slight change in the atomic radius. Generally, we can consider as we move from left to the right. It means from scandium to zinc, there should be a decrease in the atomic size. According to the general concept, as we move from left to the right, it means scandium to zinc, there should be a decrease in the atomic radius. Right? Then consider here from scandium to chromium. Atomic number 21 to atomic number 24, there will be a decrease in the atomic radius. This is the as usual concept. From scandium to chromium, there will be a decrease in the atomic radius. Next, from manganese to nickel. From manganese to nickel, there will be a constancy in the atomic radius remains as a constant. And next, from copper to zinc, there will be a increase in the atomic radius in the 3D series of elements. This is due to the two factors. First one, effective nuclear charge. Another one, effective nuclear charge. Another one, shielding effect. This is due to the two important factors. Then what is the meaning of effective nuclear charge and what is the meaning of shielding effect. Already you know about the shielding. Shielding means that is a protection or protective layer. There should be a protective layer. If there is a protective layer, then there will be a protection will happen. Like this, the shielding effect also will happen in this series of element, and also effective nuclear charge also one of the most important factor which we can observe in the periodic, which we can observe in the all the elements in the periodic table. These are the two important factors. Effective nuclear charge means consider an atom. This is the nucleus. Consider this nucleus. Around this nucleus, the electrons are revolving in a fixed circular path. This is the imaginary structure for the atom. Next, take an example, scandium. Scandium atomic number 21. Scandium atomic number 21. It means its electronic configuration Ar, argon electronic configuration. Next, 3d1 4s2 is the electronic configuration for the scandium, right. Next, here scandium, consider this is a 3d atomic orbital, this is 4s atomic orbital. 4s is the higher atomic orbital, hence it can be written in the outermost shell, and 3d is the innermost shell. Like that I have written here 3d series and 3d atomic orbital. This is the 4d atomic orbital. Next, we can allot the electrons here. In the 3d series of element, only one electron is there. 3d series of element, one electron is there. In the 4s atomic orbital, 4s series, two electrons are there. Right? Two electrons are there. Next, this only one electron will not shield these two electrons. Right? Shielding effect means already I told shielding means there is a protective layer. This only one electron will not shield these two electrons. It means there is a less shielding effect in the scandium. In the scandium, less shielding effect. Right? In the scandium, less shielding effect. Next, in the titanium. Next, it means the electron 3d to 4s2, right? The electronic configuration is 3d to 4s2. Next, one electron will enter here. Then also it will not shield. Then also it will, there is a little bit shielding in between the 3d orbital and 4s orbital. Then shielding effect. It means increases at that time as compared to scandium, titanium. As compared to scandium, that for the titanium there is a decrease in the atomic size. Next, for the vanadium, 3d3 4s2, another electron will come here. Another electron comes into 3d atomic orbital. This will shields more. It means there is a more shielding effect. As a result, there is a decrease in the effective nuclear charge. Decrease in the effective nuclear charge, increase in the shielding effect. Then also there is a decrease in the atomic size. Next, chromium. Atomic number 24. 3d4 4s2. 3d4 4s2. Again another electron will enter here. It means more as a result, whenever the more electron will enter into the same atomic orbital, this will shields the outermost electron. It means shielding effect is more. Atomic nuclear charge means nucleus has the affinity towards the outermost electron. It means it has the capacity to drag the outermost electron towards itself. There is increase in the innermost shell, but there is no capacity to attract the outermost shell towards itself. At that time there is a still decrease in the atomic size. Next, for the manganese, 3d 5 3d 6. For the manganese 3d 5 4s2. Again one electron will enter into the 3d atomic orbital. Again one electron will enter into the 3d atomic orbital. Like that continuously electron adding into the same shell. At that time this will shields to the, again electron will enter into the same atomic orbital. There is a shielding, there is a increase in the shielding effect. Shielding effect going to increase increase on the 4s atomic orbital. At that time there is a little bit decrease in the effective nuclear charge on the 4s atomic orbital. At that time from manganese to nickel there is a constancy in the atomic radius, and at the final there will be a more shielding effect. As a result, more shielding effect, then the effective nuclear charge going to complete decrease. At that time there will be a decrease, there will be a further more increase in the atomic radius of the element. Copper and zinc, they are having the more atomic radius as compared to the scandium and up to scandium to nickel. There is a increase from scandium to chromium, decreases. From manganese to nickel remains constant, and from copper to zinc there is a again increase in the atomic radius. This is due to the shielding effect of 3d atomic orbital upon the 4s atomic orbital. It means this innermost shell will shields the innermost shell electrons will shields the outermost electron. As a result there is a decrease in the effective nuclear charge and increase in the shielding effect. This is the most important factor you should observe. You are observing here. There is the as there is one concept consider here. Whenever the effective nuclear charge going to increase, the shielding effect going to decrease. Keep it in mind. Whenever the effective nuclear charge going to increase, shielding effect decreases, or whenever shielding effect going to increase, vice versa. Whenever the shielding effect going to increase, the effective nuclear charge going to decrease. This case will happen in the 3D series of element. In general, we can observe there is a gradual decrease in the atomic radius as we move from left to right in the periodic table. But in the 3D series of element, we can observe there is slight variation in the atomic radius of 3D series of element. It means from scandium to chromium decreases, from manganese to nickel it will remain constant. Next, from copper to zinc, again there is a increase in the atomic radius. This is due to the two factors, effective nuclear charge and shielding effect. As the shielding effect becomes more, the effective nuclear charge becomes less. As the shielding effect going to less, the effective nuclear charge going to more. This is the concept you should keep in mind. This is about the atomic radius of the 3D series of element. And next property or next trend of the 3D series of element is ionization enthalpy. Next concept is ionization enthalpy. Ionization enthalpy. Or enthalpy of ionization, or also we can call it as a enthalpy of ionization or ionization enthalpy. Already you know about the ionization. Ionization means, consider this is a scandium atom. Scandium atom, atomic number 21. It is having the electronic configuration Ar up to argon. This is a completely filled electronic configuration. Next, radium 4s2. This is the electronic configuration for the scandium atom. Whenever it is having the unpaired electron, whenever it is undergo excitation, at that time it will loses the electron and it will Sc plus. Sc is scandium plus. At that time scandium plus means it is losing the electron. It is losing the electron means it has converted into scandium ion. It has converted into scandium ion. Next Sc plus 3. Then also it is scandium ion. It means it is losing the electron or it is gaining the electron. Then it can be converted. It will attain the respective charge on the element. Then that is called as the ionic charge. Then this mechanism itself is called as the ionization. Then during this process there will be a change in the enthalpy. That enthalpy itself is called as the ionization enthalpy. In the ionization, in the 3D series of element, the ionization enthalpy increases as we move from left to the right. The ionization enthalpy going to increase. Ionization enthalpy going to increase as we move from left to the right in the 3D series of element, because there is a decrease in the atomic size. Decrease in the atomic size. As the atomic size going to decrease, the ionization enthalpy going to increase. That is the concept already you know. As a result, there is a increase in the ionization enthalpy. This means first ionization enthalpy increases as we move from left to the right in the periodic table. And next, second ionization enthalpy. Second ionization enthalpy remains constant. Second ionization enthalpy means first ionization enthalpy means to ionize the element or to ionize the atom. It means to remove one electron from atom. This is called as the first ionization enthalpy. To remove the second atom of the element, this is called as the second ionization enthalpy. It means first ionization enthalpy is more in the 3D series of element, and second ionization enthalpy is less as compared to the first one. And then this one is called as there is a constancy in the second ionization enthalpy in the 3D series of element. This is about the ionization enthalpy. Totally, first one is the atomic radiation, second one is the ionization enthalpy. Atomic as atomic radius going to decrease at the as well as whenever the atomic radius going to increases, ionization enthalpy going to decrease. Whenever the ionization enthalpy or whenever the atomic radius decreases, ionization enthalpy increases. Then for this we can write an relation: atomic radius inversely proportional to ionization enthalpy. It means when the atomic radius is going to increase, ionization enthalpy going to decrease. By this concept we can understand that ionization enthalpy, there is a increase in the ionization enthalpy as we move from left to the right in the 3D series of elements. This is about the ionization enthalpy. In the next class we are going to discuss about some more concepts of some more trends of the 3D series of elements.